There's an animal called the Mantis shrimp. It's the size of your index finger, and it generates, with a single strike, a physical phenomenon that requires the temperature of the surface of the sun. It does this repeatedly, several times a day, as a feeding behavior. Not a weapon, not a defense, a feeding behavior. This episode, we break down what the Mantis shrimp actually is, what its punch produces, what its body shouldn't be able to survive, and what its brain is doing that has no human equivalent. 3 engineering solutions still unsolved by the species currently running the planet. We call it a shrimp. That's our first mistake. Odontodactylus scalaris, the peacock mantis shrimp. Shallow tropical marine environments across the Indo-Pacific. 10 centimeters long, 16 photoreceptor channels, humans run 3, a striking appendage called a dactyl club that accelerates at 10,000 G. That's faster than a .22 caliber bullet leaving a barrel. It has been around for quite some time. And in that time, it built 3 things that human science and engineering are still working to replicate. Most people know the punch. The punch is the beginning, not the story. The story is what the punch creates and what the animal survives every time it creates it. When the dactyl club moves through the water at that velocity, it creates a localized pressure drop. The water vaporizes, microscopic bubbles form in the wake of the strike. Those bubbles collapse. The collapse of a cavitation bubble is not a quiet event. It produces a shock wave, a flash of light, a phenomenon called sonoluminescence, and a temperature spike. Researchers measuring conditions inside collapsing cavitation bubbles from mantis shrimp strikes documented temperatures reaching approximately 8,492 degrees Fahrenheit. The surface of the sun, 9,932 degrees Fahrenheit. The mantis shrimp punch produces, in the water between its club and its target, a temperature within 1,400 degrees of the surface of the sun. Briefly, localized, gone in microseconds. But real. A 10 centimeter crustacean generating stellar surface conditions. The shock wave from the bubble collapse hits the target at a fraction of a second after the physical strike itself. The mantis shrimp doesn't hit you once. It hits you twice. The second time with a collapsing star. Here's the engineering problem, though. An object striking hard surfaces repeatedly at those velocities should destroy itself. The impact stress, the cavitation shockwave reflecting back through the club itself. These forces should fracture the material within a small number of strikes. The dactyl club doesn't fracture. Researchers at UC Riverside analyzing the club's internal structure found it built in helicoidal layers. Fibers arranged in a rotation spiral that distributes impact stress in 3 dimensions simultaneously, rather than concentrating it at the point of impact. A material that absorbs and redistributes forces that would shatter conventional engineered materials. The study was published in Science, funded in part by the US military. The findings are currently being applied to the design of body armor, vehicle panels, aircraft components. A shrimp that has been refining this structure for a very long time produced an engineering solution that human materials science is actively working to replicate. Not subscribed yet? Fix that now. Mantis shrimp has been on the Earth for thousands of years. It developed a striking appendage that generates near solar temperatures. A structural material human engineering is actively trying to replicate, and a visual system that processes reality through a framework we have no access to. Every time researchers think they understand what the mantis shrimp is doing, the next study finds a layer underneath that requires a new model. A 10 centimeter crustacean quietly generating unsolved problems in multiple scientific disciplines for decades. Most people know it as the shrimp that punches. That's the least interesting thing about it. Subscribe for more creepy science, dark history, and bizarre facts. Learn hard, live loud. I'll see you in the next one.